The second hardware component of the PLC is the Central Processing Unit or CPU, and it is the most important part of the PLC system actually. And because the performance of the PLC totally depends on the how fast the CPU can process the received data from input devices and send the command to the output devices. Usually, the CPU is either built in into the fixed PLC system, like in the small type or the fixed type of the PLC, or it can be plugged as a module here into in the type of the modular PLC system. So some company they call it CPU unit, some they call it the controller or the processor, but at the end it's perform the same task in all PLC system by processing the data or the received data from the input devices and send the command or the take the action to perform the control on the output devices. We can see here the processor module as we see it before in chapter 4. It consists of two main parts. One is the CPU or the central processing unit, and the other is the memory. So the CPU here is used to execute the program or the software ladder logic program that we are going to install inside or to install inside the CPU to perform the control of the operation of the process, and the memory here, which is responsible to store the program along with the retrieve of the data. So the memory can have to need to store the program, which is the need to perform the control, and at the same time it will store the data that will be retrieved from either for received from the input devices. Usually the CPU here also will receive its input from the discrete or analog input devices, and also it will communicate with other CPUs or with other PLC input output device. The PLC actually it's power supply by using the power supply unit here, or the main same like the CPU, it will be get the power same like the other input output modules, which got the power from the main power supply from the back plane here. So you can see here when we plug in the module of the CPU or the modules of the input output devices, it will got the power from these ports. The power supply usually is general is going to convert the AC input because all the CPU or the microcontroller here will operate on the DC. So this power supply will receive the AC voltage from the mains, and then it will convert it into the DC voltage, which is required for running the CPU modules and also the input output modules. The CPU contains the similar type of microprocessor for the personal computer. So, for example, the PLC here will use the same microprocessor, either I mean, or similar microprocessor like the microprocessor for the laptop, for the PC, and so on. But it's more, it may be more powerful or more suitable for the application required for the industry, not for the personal computing or purpose of personal computing, as we mentioned before, since it will only run one program in continuously to perform the control operations. So we can see here, this is the CPU module here. It has it has the switch here, and it has also LEDs or uh, indicators on this part. Later in the next, we will see why we need this all LED and switches. Actually, the some of the PLC system may use two CPUs or two microprocessor. I mean two processors. One of the processor will be the main, the other one will be like a backup. In case of the fault of one processor, the other processor will be in service. Okay, so it's more. They use this type of duplicate or redundant processor to increase the system reliability or the system stability. Here we can see the status of the LED and the switch and so on. This is the front view of the CPU module here. And in the front view here, we have some indicator on the top. This indicator represent the status of the CPU module. So if the CPU module is run, so it will this indicator will be on, it will be run. If the CPU module has a fault, it will be faulty. This will be, for example, the indicator will be on. If the battery of the CPU module, actually, we have a battery here. In this part, we have a battery for the CPU module. The battery is not to power the system, but it's only to keep the important information for the CMOS RAM, which is related, for example, for to keep the date and so on. So for usually our laptops or PCs, they have this type of battery, and this if even you close or you switch off your laptop, but the clock and the time, the date still updated, is still correct, because actually there is a battery here for the CMOS RAM, which keep the date of the and time updated without stop. Okay. Otherwise, if your CMOS RAM battery is finished or is exhausted, so always when you run your laptop or your PC, you need to reset your time and date every time you switch it off and switch it on again. Okay. So the same here in the CPU modules, there is a battery here to keep the date of the and the time or and the important information of the CPU for the of the CPU model. And usually this battery lifetime is up to 10 years, for example, or 20 years. It's very long time. But in the case of the battery got a problem, so it will show you indicator here that the battery is damaged, I mean exhaust, or need to be replaced. Then we have here indicator for the connection for the RS module. If you connect to RS module, this will be RS232 will be on. For the Ethernet module, Ethernet port, if it's connected, it will show the Ethernet port. If the system is forced, that means forced to be switched off. Also, it will indicate this indicator. This regarding the all these indicator on the front side, front view of or the front face of the front panel of the CPU modules. And we have here selector switch. Actually, we need to use this selector switch in case we want to uh, change the program inside the CPU, inside the PLC. So we will need to put it on programming mode. If we want to run the system in the normal condition, so it's become in run mode. If you want to connect your Ethernet, I mean, you connect through Ethernet to your laptop to perform some monitoring through laptop or through PC and so on. So we need to put it in the remote mode. Okay, so we have to use the or select or put the switch on the correct position, and usually it will be in the run mode or in the remote mode, but in the program mode only in the case we want to change the program inside the CPU. We have here the key. This key actually, or key switch here, is used to fix the place of this selector switch. So nobody can, only the BIC can change. The person in charge can come here to change the position of this selector switch. Otherwise, it will be both in some position, and it will keep the key in the same place, so nobody can uh, change the selector switch, because the change of this selector switch will make problem to the software or to the program inside the CPU unit. Here is the side view of the PLC system, I mean of the CPU modules. And when this module is go inside, this connection will go to get the power from the back plate power. And here the hardware address here will be indicated on this place, and the memory modules here will be placed here. So we said the CPU modules, it consists of the CPU and also the memory, so the memory will be placed on this part. Many electronic components actually found in the processor modules here or other type of PLC modules are sensitive to the electrostatics. So it's not good to keep them if we do not use these models or this component, we need to keep them in a static shield bag. So to avoid the damage of electronic device by the electrostatic charge. We'll continue in the next video.